Welcome back, climbers. Chris here with Bartlett Arborist Supply. Today I wanted to go over some basic material on weight ratings with rigging and climbing components. So make sure you're checking us out on Instagram, Facebook, TikTok, YouTube, all the delicious content everywhere. I wanted to go over these basic numbers, weight ratings on your rigging equipment, your climbing equipment, so that way you know when they are going to break in real life scenarios and not your equipment breaking during that real life scenario. Let me start off by mentioning that I have always wondered how the manufacturers got these numbers, came up with these numbers on when these components break, and the variation between half-inch breaking numbers to other half-inch breaking numbers. It always kind of boggled me. So let's break it down. Real smooth, real easy. We'll go over just the basic stuff in real life scenarios. Also, by the way, if any of you want to see some of this material snapped, you know, like in real life, we're gonna throw some nasty loads into it, big old logs, try and break some stuff and measure those forces generated, drop a comment down below. Give me a thumbs up, a hell yeah, anything you want. Let me know if you want to see that, because the more comments I can get, the more I can convince them to let me break stuff on video, you know, for science purposes. Anyways, let's get back to it. There are 3 common weight ratings that you need to understand. The manufacturers will come up and list any 3 of these or all 3 of these numbers when it comes to either hardware or any of these textile components. Those 3 are going to be average braking strength, ABS, minimum braking strength, MBS, or working load limit, WLL. Now, unless you are Nibbles McSpruce Tips and you're out there shaping hedges, these numbers apply to you, because you're climbing with ropes, you're rigging with ropes, and you're rigging with gear that you need to know the numbers on. So average braking strength, that is a number that is somewhere in the middle, okay? When a manufacturer loads this, spliced, not spliced, whatever, they get a variation of numbers from way down here to way over here. That average braking strength is that number somewhere right in the middle. I don't like this number personally, and I know a lot of other guys don't either, because we don't know where on this spectrum, which polar opposite those numbers went to. 200 plus or minus, 2,000 plus or minus, 20,000 plus or minus. We just don't know. So it's not always a great number to go by. Furthermore, when a manufacturer tests these products, it is done in a very calculated, climate-controlled, very specific environment, and I'll get into that in just a little bit. But let's move on to MBS, minimum brake strength. This is a number that I definitely like a lot better than ABS. Minimum braking strength is the absolute lowest number that any of these broke at during their testing protocols, okay? So MBS can have valuable impact on what we're doing, because it can derive a number that we can use in real life scenarios. So let me read you something from the Teufelberger data sheet on their rigging ropes. Now, if you've purchased any of the custom slings here or any of the splice components here that are custom from Bartlett, I always include the Samson and Teufelberger rigging protocols in there, which has some really good, useful information. So Teufelberger lists that any given data for ropes are new, dry, and tested under laboratory conditions which are climate controlled. All loads are under static conditions. Static meaning it is a pull and it holds. No dynamic forces being generated. The surrounding conditions, weather during this testing, must be considered perfect and or, as a rule, humidity levels no greater than 50 or 60%. It also states that humidity can reduce braking strengths and loads and increase elongations. So essentially the water seeps into any of these cordages. It allows it to have like a little bit of like lubrication, and it slides and it moves more, which causes friction and causes the loads to change. It goes on to state that especially wet ropes can be affected. High or low temperatures may negatively impact braking loads. The same holds true for dirt. Influences of sunlight, so UV degradation. We work outside, so these ropes are always get smashed by sunlight, and that really tears down stuff quickly. And that will also reduce braking loads, so please take that into consideration. They finally state that ropes become stiff when they freeze and therefore behave differently. Tree secretions, i.e. resin, slimy residues, and debris may create conditions comparable to adverse adhesives, lubricants, rope behavior in pulleys, knots, etc. Kind of goes on and jumbles around a little bit, but basically what they're saying is that their ropes are tested very specifically in a dry, new condition. If you have any other factors in play, which we always do, these ropes are going to break lower or quicker or with less friction. So there's always those things that we need to take into play. So back to MBS. Let's talk why that number isn't always a great number to use. It's in a testing scenario, perfectly fine. But when a manufacturer tests any of these ropes and they pull on them, generally how they achieve a very high number is that they will slowly draw this to like 4 kN, 5 kN, so, you know, several thousand pounds. They will hold it, let off, pulse it again, pull it to another specific number, hold it for 30 seconds, 60 seconds, 2 minutes, and then they draw it very, very slowly. So in some cases, I've heard of even a centimeter a minute. So like the width of your pinky fingernail until it breaks. Really, really slow, which gives it a really high number. None of us do that in real life. None of us. We are never, ever, ever going to use that type of rigging. It's never going to be coming into play. Okay? So that's kind of why I don't like to use either ABS or MBS. What I do like to use those numbers for is to achieve another number, WLL, working load limits. Now, in dynamic rigging, which is what most of us do, negative rigging, where we are dropping material into our hardware or our ropes, we are generating high exponential forces that are going to create these crazy numbers in a split second and then dissipate. Those are real life scenarios. And we can easily take working load limit and apply it to all of these, even if it is not listed by the manufacturer. So take MBS number. Our rope braid here, Samson stable braid, 1/2 inch, in spliced configuration, has an MBS of 8,800 pounds. Take 10% of that, 880 pounds. That should be relatively our working load limit. So 8,800 pounds. What that's going to allow us to do is cycle in dirt, abrasions, usage over time, wear from UV degradation, cycles to failure, all of these things that are going to compile up. And if we're not exceeding 880 pounds, which would be a good number to use in new condition, we can guarantee that we can repeatedly use this rope over and over and over again. And that can be applied to any one of these ropes here. Something as small as this 6mm Dyneema that has a minimum break strength of roughly 7,900 pounds. I can load this in a real life scenario with a working load limit to about 790 pounds or 750 pounds, which is great. So that's a number that we can use out in real life. So the manufacturer can give us any three of these numbers, but we can always achieve that one number that we want to use. Now I understand that a lot of this stuff says your MBS is going to be like whatever, 20 kN or 20,000 pounds if you've got something like this 3/4 Samson stable braid. But that's not a realistic number because we are absolutely introducing high energy, dynamic load forces that are loaded with friction-based materials, dirt, debris, grime, all sorts of stuff that we cannot calculate. I mean, the variables in rigging are so extravagant. When we try and get a rough guess on something, there's always these other factors that want to come into play. So a working load limit is really going to get you close to where you want to be. Now, in this Samson pamphlet for their rope inspection, let me read you a little bit of this. It states that working loads and safety factors, or in the working loads and safety factor column, working loads are the loads that the rope is subjected to under expected or typical working conditions, what we normally do. For rope in good condition with appropriate splices and finishes under normal service conditions, working loads are based on a percentage of the breaking strength. So again, every manufacturer has a different number that they want to factor in, but 10% is a really good number that isn't going to be on the high end or the low end. We're going to be kind of right in the middle with that 10%, where you're in that safe zone for working consistently and safely. It also goes on to state that normal working loads do not account for dynamic or excessive dynamic conditions such as high shock loads, long-term sustained loads, nor the extra caution required where life, limb, valuable property are involved. In this cases, a higher factor for working load limits should be used. Okay, so essentially that one big giant number that you're looking at, that 5-digit number, that 6-digit number that you're looking at with a lot of this equipment, we need to cut that down. We need to get it down to about a 10% number, and you will be in a very safe zone for repetitive use on any of this equipment. Now, the majority of arborist gear is going to be a polyester. Polyester is a very great durable material. Polyester shirts, polyester ropes. These shirts last a long time. You can wash them a whole bunch. You can go out and work. Most of the chainsaw pants and other gear that we have is going to have some sort of a polyester base to it because it's very durable and it lasts a long time. It stretches out, it works well, okay? The same goes with the ropes, but it's made slightly differently. This is made to be more abrasion resistant than some of the polyester like than what's in this shirt here. And then there's also HMPE fibers or high molecular fibers, and then there's UHMPE fibers, ultra high molecular fibers. Now, that would be like this Dyneema, and then this one actually has a little bit of Technora in it. So that is going to be a different realm. Polyester stretches and can absorb energy really well. So with good abrasion resistance and being able to stretch, it can return to a safe working property as long as you're not exceeding that working load limit. Products like Dyneema, which is an HMPE, or some of them that are UHMPE, do not stretch. They have little, like a very static, the most static rope you have ever felt in your entire life. So these have a really, really high number. So again, this is a 7mm cordage or 6mm cordage with a 7,900 pound minimum breaking strength. This is a 10mm with a 21,000 ABS, 19,000 MBS. That is 3/4 Samson stable braid numbers. That's crazy. The problem is it doesn't stretch. So when we dynamically load things like we do when we're negative rigging, this will break. Now, manufacturers will combine those two. So they will take HMPE fibers and use them in specific rope categories to get those really good numbers, but also allow the stretching and the shock absorption, that energy to be dissipated when we're doing negative rigging. Okay, so I mean, they can do lots of stuff all over the place, but we're always back to that working load limit. We got to take whatever numbers they list and then factor it into where we can be safe and accomplish the job over and over and over again without failure, okay? Now, when it comes to these different types of constructions here, double braids like this Samson stable braid here, and or this Cousin A-Trax, when they state double braid, it is a braided rope inside of a braided rope. So on this Samson stable braid here, we have this nice braided core over top of this braided exterior. And I can actually pull this out for you so that way you can see. The reason why this stuff is so strong and does so well in these spliced conditions is because this rope continuously rides back into itself and creates a consistent loop. Where if we tie knots in ropes, we have all these sharp bends. Every time that we have these sharp turns or bends, the rope gets overloaded immediately at that point, which causes a lot of high friction areas. Splices will reduce that. Knots, we know, can reduce a rope strength by like 50%. In some cases with certain knots, 60%. So take that 20,000, 10% of it, 2,000 pounds. Tie a knot in it and then load this, we could potentially be reducing this to 1,000 pounds, where if we have a splice, we can keep it right around 80, 90%. So there's always good things that factor in there. Some of the other constructions, these 16-strand ropes. These are cover-dependent ropes, and they have individual cores, which are called parallel cores. So this is just a twisted polyester. Now, the strength rating of a 16-strand climbing line is merely based off of this cover. So these are cover-dependent weight rating ropes. So if we damage this, that reduces the number immediately as far as safe working loads or what this rope can handle. Yes, this is strong. However, in a spliced configuration, or even if you're tying it, we're still reducing the number. It's just meant to keep this round shape. Single braids, such as these hollow braid 10X cordages, or these ultra slings here. These are ridiculously strong, and I do mean ridiculously strong. 1/2 inch, 13 millimeter, we're at somewhere around 13,200 for an MBS. 1/2 inch double braid, 8,800 MBS. Now, the downfall with a single braid is these do not work well because it's just a hollow rope that we can easily punch our thumb through here. Under high friction, so like moving rope scenarios, like if we were to rig with this as tying it off to limbs and lowering stuff down, in high friction settings, this will quickly run through its life cycle and be done. Double braids, they share the load between this inner braid and this outer braid. So you can abrase this outer and get that fuzz coming off of it, and you're still going to have a decent amount of that original breaking strength that we're looking for. However, back to what like Teufelberger and Samson were saying is that no matter how much the rope is as far as tensile strength, if you got a whole bunch of debris in there, if it's worn out, if it's been overloaded, if it's wet, if it's been abused and thrown away, then or back in the truck nasty, the numbers are still going to decrease. However, these hold up to friction a lot stronger than these are, which is why we use these for slings as opposed to using some of these big pieces here. Okay, so just to summarize, ABS, average braking strength, not a good number to use. MBS, minimum braking strength, definitely a number that we can achieve 10% of for our working load limit, which is the number you want to focus on. Double braid ropes, great for in-tree rigging, lowering limbs, logs, good dynamic forces. They share the load between cover and core. Single braid ropes, great for making slings, rigging slings, and or Dyneema friction slings, or non-friction slings. Don't get that mixed up. 16-strand ropes, great climbing ropes. Again, cover dependent. That core is just in there to keep round shape. And then, of course, you have some of your high-end performance 24-strand climbing lines. Most of them are going to be a double braid construction, which share that load 50-50 or 60-40, somewhere around in there. And then, of course, you've got some of these, which are some of the newer age 24 strands, which are going to consist of a braided parallel core. Crazy stuff. They get into some wild things nowadays. Anyways, make sure you're using those MBS numbers to achieve your working load limit. So, as I said earlier in the video, comment if you want to see us try and break some of this stuff, you know, for science. Please comment below. I would love to hear from you guys. I would love to hear from everybody to make sure that you want to see that type of material, because we'd love to destroy some stuff so that way you can watch it, you know, for science, right? Anyways, thank you so much for checking out this video. Again, we appreciate you so much. Everybody, hope you had a great holiday. Hope your year is fantastic. Thanks for sticking around and thanks for watching this video. Facebook, Instagram, TikTok, YouTube, Bartlett Arborist Supply. Appreciate you, climbers.